Right, trig application problems. Let's start with the first one, and we'll just have a look for the function and highlight it. Right, we'll start by thinking about what the graph of that function would look like. The positive 30 here, we'll put our axis at 30. The 24 is the amplitude. So my wave is going to go 24 that way. 30 plus 24 is 54. And subtracting 24 that way takes me down to a value of 6. So now I have my y-axis. It's a sine curve, well that's an upside down sine curve. The period hasn't changed. There's no number in front of the t, no coefficient of the t. It's just 1t, so the period will still be 2 pi. Remembering whenever you're doing a word problem, we always answer in radians. So the first step, of course, is to make sure that your calculator is in radians, or you will never get the problem right. Okay, now this is a sine curve, and it's a negative sine curve. Sine curves start in the middle and go up normally, but this is a negative one, so it will start, means it's reflected in the x-axis. Sine curves being reflected in the x-axis. You can jump onto your calculator and put that in and have a look at it. Change your view window. You'll need your x-axis to go from 0 up to 2 times pi, which should be a value of about 6 point something. And your y-axis you could make go from 6 up to 54. And your graph should look like this on the calculator. Right, after how many seconds will the reflector first be 50 centimetres above the road? So our reflector is going round and round. It starts in this position on the wheel, and then it goes down closer to the road, back up to the top of the wheel, back round to the central position. After how many seconds will the reflector be 50 centimetres above the road? Right, so I'm going to put a line along here at 50. There are many ways to answer this problem. I can see that I'm looking for this value here. My x-axis t is time. After the wheel starts turning in seconds, this is time in seconds. So time is ticking along, and this is the height in centimetres of the reflector above the road. And we want to know the first time that it's at a height 50 centimetres above the road. You can put the line y equals 50 into your calculator, hit G solve and intersect. Will give you a value of x equals 4.13 seconds from the beginning, 4.13 seconds, and the reflector will be 50 centimetres above the road. Remembering that 2 pi is about 6 point something, so 4 sounds about right. You could also do this question going to G solve and xcal. We want to calculate an x value, so we could choose G solve and xcal. Put in the y value of 50, and up comes an x value of 4.13 seconds. Right, you can pause and have a go at that if you like. I'll need to erase that to make some room for the next question. Right, for the next question, let's find a highlighter and highlight the equation in the question. So here's my formula. It's a cosine graph. I can see the amplitude is going to be 7, so the height of the wave will be 7 up and 7 down. There's nothing added on the bottom, so the axis must run through 0 and go up to a height of 7 and down to -7. So I've got my y-axis ready for my view window. This is a cosine graph. You could go into your calculator and have a go at plotting it as it's written. It's really important that when you put this function into your calculator, 7 times cos bracket, we go 8 times pi divided by 3 times, and then we're using the x button for the variable. I understand the variable is t, but on our calculator we use the button with the x theta t on it. So it's important that you put this in very carefully into the calculator. 8 times pi divided by 3 times the variable. Put it in like that to make sure you get it right. Okay, now our cos graph starts at the top, goes down like this. Now it's going to be difficult for us to know our x-axis. Of course, you could try 2 pi. If in doubt, try using an x max of 2 pi. There's a formula that helps us to know what this value would be. That would include one complete cycle of the cos graph. And that is the new period is 2 pi, which was the old period, divided by the coefficient of the variable, or b. So in the formula we've been using, y equals a sine bx plus c, I understand that b changes the period, and this is how. The new period will equal 2 pi divided by b, which in this case looks a bit complicated, but that's what we've got calculators for. So if you want to find your calculator and very carefully work out this using brackets, you should get a value of 0.75 seconds. Time along the x-axis, and this value is 0.75 to get one complete cycle of the cosine curve. You try changing your view window, x-axis to go from 0 to 0.75, y-axis from -7 to 7. Carefully put this function in and you should come up with that curve. Calculate how long it takes a point on the rim to travel from directly below the axle to directly above. So how long to get from the bottom all the way around to the top, from its lowest point, which would be here, up to its highest point, which would be here. We want to know how long between here and here. Clearly, if this is 0.75, then this value here, this x value here, will be halfway between 0 and 0.75. And on the calculator, 0.75 divided by 2, we get a value of 0.375. So from here to here is 0.375, and from here to here is 0.375. So the answer to our question, how long it takes a point to get from here to here, or alternatively from here to here, is 0.375 seconds. You could perhaps watch this again, make sure you're using your calculator and trying it.